Hi, I'm Jingwei from National University of Singapore. It's a pleasure to present to you Q&A, query-based representation learning for multi-track symbolic music rearrangement. This is a joint work with Zhao and Wang. So what is music rearrangement? In the first place, we refer the term arrangement to the form or style of a piece of music. In music composition, we often design textures and voicing to arrange and conceptualize a musical idea. For example, here we have an arrangement in piano. In more general cases, arrangement can have more tracks and instruments involved. And on top of that, one piece can also be rearranged to convey new feelings. Such rearrangement scenarios include orchestration, from piano solo to multi-track music. And here is an example. And the opposite direction would be piano cover generation, which is also a rearrangement task. Apart from that, we also have re-instrumentation, using different instruments and tracks. Last but not least, we have voice separation, which rearranges a piece into a preset ensemble format, such as Bach chorales in 4 voices. Apparently, these 4 tasks look quite different with each other, but essentially we are doing the same thing. That is, we keep the overall structure of the original piece, and we modify the textures and voicing. In our work, we regard such overall structure as content and the unique textures and voicing as style. Then, any kind of rearrangement is essentially style transfer. Therefore, we wonder if we could use one unified framework to address each individual task. So in this paper, we focus on the representation learning of 2-bar multi-track music segments. We first format each individual track xn as a 2D piano roll. Each piano roll is a p/t matrix. We then use xmix to describe the track-wise condensed mixture, which is also a p/t matrix. The mixture here contains the overall musical content. And we further use track functions to describe the textural style of each track. We define pitch function fp and time function ft. Specifically, the pitch function is a pitch histogram, and it indicates the key, chords, and pitch ranges of the specific track. And the time function is essentially the progression of voice thickness, and it indicates the rhythmic density and groove patterns. To this end, rearrangement is essentially to reconceptualize the musical content with the guidance of track functions. To realize such, we develop our model architecture in 4 parts. The first part is a mixture encoder. It takes the mixture and produces a latent mixture representation. The second part is named function querynet, which is essentially a VAE. The encoder here takes the track function and produces a latent function representation. Recall that in our work, we define track functions as 1D vectors representing texture patterns. And since we have n tracks in total, so querynet is performed n times for each track in parallel. The third part is a track separator. We input the mixture and track functions together to the separator and we aim to separate individual tracks from the mixture. The final part is a track decoder, which reconstructs individual tracks from latent representation. Overall, if we regard mixture as content and track functions as style, then our model essentially rearranges the content with a query of styles. Here we note that our model is self-supervised. It takes a mixture and track functions and reconstructs individual tracks, all of which can be obtained from unlabeled data samples. We use two datasets to train our model. The first one is Pop 909, which has around 1,000 pop songs in piano arrangement. And the other one is SLog 2100, which has 2,000 multi-track arrangement pieces. At inference time, a well-trained model can rearrange a piece X using the track functions from a new piece Y, which can be freely selected by the user. For example, when we draw X from piano solo and Y from a multi-track piece, we will be using the track system of Y to orchestrate the content of X. And conversely, we'll be doing piano cover generation. When we draw both X and Y from multi-track pieces, we'll be using Y's track system to re-instrument X. By extension, if we don't select Y from existing pieces, if we predict track functions directly from the input mixture and use them to separate the mixture, then we can also address voice separation. We name our model Q&A, which is short for query and rearrange. It means that we simply query the mixture with certain track functions and will rearrange the piece. To evaluate our model, we first conduct a subjective experiment and introduce 4 evaluation metrics. Comparing with several ablation variants, our proposed Q&A produces the most natural and musically pleasant results. We also compare our model with prior works on specific rearrangement tasks, including orchestration, piano cover generation, and re-instrumentation. In most cases, our model performs significantly better. For voice separation, we evaluate the precision objectively. We see that our model is generally comparable and in certain scenarios sufficiently better. Finally, I'd like to showcase our model's rearrangement performance. Here is an 8-bar piano music segment. We will orchestrate this piece later on. And this is the orchestration result by Q&A. Here we highlight certain key points. We can see that the orchestration result preserves the overall harmonic and melodic structure from the original piece, and it also introduces new group patterns, melody improvisations, and rich textures in a total of 11 tracks. In other words, our model makes a very good job balancing faithfulness with creativity for music rearrangement. That is all about our work, and I hope you enjoy. For more technical details, please feel free to check our paper, code, and demo.